In the previous video, I explained to you how to evaluate a function. We also worked with some functions that were straight lines. In this particular video, we're going to describe what's called a piecewise function. So what is a piecewise function? A piecewise function is easily recognizable because it has this little brace, and normally there's two or more equations written down after the brace. So in other terms, a piecewise function is a function made up of multiple pieces, and those pieces could be straight or bent. So for example, this one right here is going to be a straight line that points down, the next one is going to be a horizontal line, and the third one is going to be an upside down parabola. So when you put them all three together, you get the complete full picture of the function. These are very important, especially when we get to the section where we're talking about continuity and whether the function is continuous or not. And they have some really good uses in real life. Now, the point of this problem that I'm doing right now is to show you how to evaluate one of these functions. So for instance, the first problem says f of -3. So they want us to know what is the function going to give when the x is -3. Remember, this is supposed to represent the x value that you're inputting into the function, and f of -3 is supposed to represent the output. So what's the output when the input is -3? Now, this could tend to be a little bit confusing, so let's explain it one step at a time. First of all, you're going to look at the -3 and you're going to decide whether -3 is less than -1 or greater than -1 or equal to -1, but less than 3, or greater than or equal to 3. So which one of these three does -3 satisfy? If you were to put -3 into all of these inequalities, would it make the first one true, or the second one, or the third one? Which one of these is true? Let's check. Is it true that -3 is bigger than or equal to 3? No. Now, is it true that -3 is less than 3 and at the same time greater than or equal to -1? This answer is also a no. So far, none of these statements have been true. If I look at the first one, is it true that -3 is less than -1? The answer is yes, this is true. So what does that mean? That means that my equation for this problem, for this particular case, is going to be -4x plus 5, because this condition was happy, was satisfied, was true. I use the equation that's attached to it, which is a -4x plus 5. And again, the x is supposed to be -3. And now all I have to do is compute some numbers. So this is 12 plus 5, which is at the end 17. And that's it. I am completely done. Now, when you're checking these conditions, it does not have to be done on the paper. It could be done mentally, and you can verify it real quick in your head, and then just check which one is true, which one is false, and then use the appropriate equation. And normally, we don't write that stuff down. So let me give this second one a shot, f of 0. I'm going out of order, but let's do it that way for now. What does f of 0 look like? So again, this question is saying, what's the output when x is 0? So again, I gotta figure out which one of the three equations is going to apply. So in order to do that, I'm going to replace 0 with all these x's, right? So all these x's become 0, and which one of them is gonna be true? Is it true that 0 is bigger than 3? No, it's not true. So I don't use this third equation. Is it true that 0 is smaller than 3, but at the same time bigger than or equal to -1? Yes. So far it seems like this is the equation I have to use. Then finally, is 0 less than -1? The answer is no. So I don't use that equation. I don't use the third equation. So the one I'm using is the second equation. And the second equation says the function is 2. And normally I don't write down the x and I replace the x with 0. But there are no x's. So that's it. I am actually finished. The answer is going to be 2. Regardless of the input here, the input is 0. Does not make any difference. The output will still be 2. Okay, let's try f of 2. Again, see if you can do this yourself. First of all, go to the function, replace all the x's here with 2. So these are called the conditions. So replace the x with 2 in the conditions and see which one of them makes sense. Is 2 smaller than -1? No. So don't use the first equation. Is 2 greater than or equal to 3? No. So don't use the third equation. Is 2 a number between -1 and 3? Yes. So use the second equation. And the second equation says basically 2. And normally I don't write down the x, but I replace x with the number 2 because the 2 was the input. In this case, there are no x's to write down. So that's it. I am finished with the problem. Okay, what about f of 1? You may have already guessed that 1 is also going to work on the second condition, which means we use the second equation, so the output is still 2. So these 3 that we just finished are all going to have the same output. That's okay, functions can do that. The next problem has f of -1. So let's find out which condition is satisfied when x is -1. So the first condition says x is less than -1, so -1 is less than -1. The second condition says -1 less than or equal to x, which in this case the x is -1, which is less than 3. And the third condition says -1 is greater than or equal to 3. So remember, this -1 is supposed to represent the x's in the conditions, which means it represents that one, and that -1. So which one of these 3 conditions is true? Is it true that -1 is smaller than -1? No. Is it true that -1 is less than or equal to -1, which is less than 3? Yes. Is it true that -1 is greater than 3? No. So what I have to do is use the middle equation for this particular part. So again, for this particular problem, f of -1 will be 2 because the second equation has a 2 and no x's to plug in. There remains to be 3 problems, f of 3, f of 4, and f of -2. Investigate and see if you can determine which equation must be used. Is it equation 1 or 2 or 3 for these parts? So for example, f of 3, which equation would you use? Would you use the first, second, or third equation? Which one of these 3 conditions does 3 satisfy? You may have noticed that 3 is greater than or equal to 3, so that satisfies the equation number 3, which is 1 minus x squared. So to investigate what f of 3 is, I have to do 1 minus x squared. So in this case, I'm plugging in a 3. So that means I should be doing 1 minus 9, which gives me an output of -8. So that works for that one. And what about the next one, f of 4? Again, you may have noticed that for f of 4, it's the same equation that works, equation 3. So again, 1 minus, 4 squared, because the input here is 4. So this is 1 minus 16, which is at the end -15. Finally, we have f of -2. So let's write it down. F of 2 is -4x plus 5. In this case, that's going to be 8 plus 5, which is at the end 13. And that's because I have to use the first equation, -4x plus 5. So I hope that made sense.